Chapter 8, Rhythms Originating in the Atria. So we're still talking about the atria. Atria, remember, is up here. Ventricles is down. They're down here. This is the sinus node where in the healthy heart, this is where the impulse is supposed to start and then depolarize or contract, or however you want to say, where it makes a P wave. Then this is the AV node. It goes down the conduction system into the ventricles where they'll polarize or make the QRS beat. That's how it does, right? So this chapter, what it's talking about is it's not starting here, but it's still starting in the atria. It's still starting here. So we'll see what rhythms that brings us. This one I might have to read some out for you so you can have a little better understanding. It says atrial rhythms originate in one or more irritable foci. It's just talking about places in different places in the atria, the ones I just showed you. Then depolarize the atria and head down the conduction pathway to the ventricles. Atrial rhythms, and indeed all rhythms that originate in the pacemaker other than the sinus node, are called ectopic rhythms. So just all the other rhythms that we're going to talk about, they're going to be ectopic because they're not like, I guess, 100% healthy how they're supposed to start in the sinus node. So it just tells you the different. It's trying to tell you that sometimes it's in the atria and then it goes out. Sometimes it comes from different parts in the atria and then, and then it goes down the conduction path. So that's where you're going to be seeing the different rhythms. It says, although the atrium is not considered an inherent pacemaker like the sinus node, AV junction and ventricle, it says the atrium is indeed another pacemaker of the heart. I'm going to continue reading a little bit. It is best known for usurping, I can't say that word, the underlying sinus rhythm and producing rhythms with rapid heart rates. Because of these heart rates, patients are often symptomatic. That means that they're feeling something. Every now and then, the atrium will fire more slowly and produce rhythms with less than 100 beats per minute. So treatment is aimed at converting the rhythm back to sinus rhythm, or that is not possible, returning the heart rate to normal levels. Atrial rhythms are extremely variable in their presentation. Some rhythms have obvious P waves, others have no Ps at all. Instead, they have a wavy or fluttery baseline between the QRS complexes. Some atrial rhythms are regular and others are completely irregular or even chaotic. Although most atrial rhythms are rapid, a few are slower. Unlike sinus rhythms, which have common set of criteria, atrial rhythms have multiple and variable possible criteria. If the rhythm or beat in question meets any of these criteria, it is atrial in origin. Let's look at these criteria now. Matching upright P's, atrial rate, the heart rate of the P waves is greater than 160 at rest. No P's at all. Wavy or sawtooth baseline between QRSs present, or three different types. P's of three different types, or premature abnormal P wave, with or without QRS, interrupting another rhythm. The heart rate greater or equal to 130, rhythm regular, P waves not discernible, may be present but you can't be sure. Wandering atrial pacemaker and multifocal atrial tachycardia. That one ends up being like this one. You see, it comes from like three different places or something like that. It's saying, and it explains it. There are rhythms that occur when the pacemaker pacemaking impulses originate from at least three different foci in the atria. Each focus produces its own unique P wave, resulting in a rhythm with at least three different shapes of P waves. WAP, or Wonder in Nature pacemaker, is an example of a slow atrial arrhythmia. That means it's not regular. And MAT, or multifocal atrial tachycardia, is rapid. WAP and MAT are exactly the same rhythm, just with different heart rates. See, WAP, mean rate of less than 100, usually mean rate in the 50s or 60s beats per minute. MAT is the mean rate is greater than 100. It's irregular. It has to have at least three different shapes of P waves. If it doesn't have at least three shapes of P waves, then it's probably something else going on. But if you see about three different types, most likely it's a WAP if it's less than 100 beats per minute, or a MAT if it's greater than 100. So some beats may have no visible P waves at all. QRS, it should still be less than 0.12 seconds. Let's see what some of these look like. See, Wonder in Nature pacemaker. Wonder in Nature pacemaker. 1, 2, 3, 4, 5. 5. So, and you see the P waves. It has one for each one for the most part, but they all look there. You have a pointy one, a small one, and then a round one. So that makes it three different, and it's 50 beats per minute. So it's a low, so it'd be Wonder in Nature pacemaker. Now the high one, you have to be very careful with this one, because this one might look a little like another rhythm, and I'll show you. It's coming up shortly. As long as you see a P wave, and sometimes if it's too hard to know, try to look at another lead. To see if you see a P wave. But still, you see a pointy one, you see a real small one, you see one that's a little bit rounder. So just, and then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have a one with the heart rate a little faster. So that's that would make it a MAT, multifocal atrial tachycardia. So that's the only two things. See, they're both irregular. You have to get you'll see later. You'll get used to seeing one that marches out real good, and this one you could tell is a little bit apart more than this one. So that's the difference between those two. Irregular, and then depending on the heart rate, you'd have either a WAP or MAT. Premature atrial complexes are very, very short, and you're going to be hearing that a lot. PACs. PACs are, it says, premature atrial complexes are premature beats that are fired out by irritable atrial tissue before the next sinus beat is due. The premature P wave may or may not be followed by a QRS, depending on how premature the PAC is. If the PAC is very premature, it will not be conducted to the ventricle because it will arrive during the ventricle's refractory. Don't worry about all that. You'll see later on what a P wave looks like. But it says it can occur at any rate, regular interrupt. So the underlying rhythm would be most likely regular, but then it's interrupted. So regular but interrupted by the PACs. The P waves shape differently from sinus P waves. The premature P wave of PACs may be hitting in the T wave. You'll see right now sometimes the P wave hides into another one, another wave, where it makes it look different, and you'll see it in a bit. So if the P wave, it says the premature P wave of the PACs may be hitting in a T wave of the preceding beat. If so, they will deform the shape of the T wave, although be suspicious when the T wave suddenly changes shape. So if you see if you see a T wave that's doesn't look the same as the other T waves, probably most likely it has a P wave hidden in there. So the QRS complexes look the same. Yeah, so it says if one T wave is different, there's probably a P wave hiding in it. Okay, so PR intervals the same thing, 0.012 to 0.20, QRS less than 12 seconds. QRS will be absent after a non-conductive P wave. The most common cause of an unexplained pause is a non-conductive PAC. That means you'll have, beating, marching out. All of a sudden, you don't see anything, but you see a weird looking T wave and then a big pause. If it's a weird looking T wave, that means that it did not do the next beat, which you won't see a QRS. That T wave has a P wave probably hiding in there, but it doesn't have a QRS. So you just have a like a little pause because you don't have a QRS. So that's a non-conducted PAC, and I'll show you in a little bit. It says if you see a pause and you're tempted to call it a sinus arrest or a sinus block, or like I just stick to pause or delay, depending on how many seconds. Just make sure there's no P hiding in the T wave inside the pause. It might just be a non-conductive PAC. Let's have a look at a PAC. You see this one? So this one is marching out, and boom, you have a premature or a PAC. This is a PAC because it came before time. It's like like we said earlier, and that's probably not a good thing, but like a premature baby, they come before time. So you have a beat, and beat, and beat. These are like spaced out almost the same. You have this one that came early. That's a PAC, and it's a PAC because it's really thin, because you're going to have PVC. PAC is atrial. Anything that's real, the narrow or very skinny QRS, it's most likely in the atrial. If you have a bigger one, like we said in the past, it's coming from the ventricle. So this is a PAC, then, and it continues back to, then remember you have a little pause, and then you go back to, then it starts beating like regular. So then you would call this one probably a sinus Brady. 1, 2, 3. You're still going to count this one as a beat. 1, 2, 3, 4, 5, 6. It's going to be, how can I say this? So if you're going to, if the computer counts this as a sinus Brady, most likely you're going to say sinus Brady with a PAC. But if you're counting it, if you're like making a quick interpretation, you'd say 1, 2, 3, 4, 5, 6. You just say sinus rhythm. It becomes a sinus rhythm because you're still counting that one. Just say with a PAC, But if the computer picks up the heart rate as sinus Brady, that means less than 60 beats per minute, then you're gonna call it sinus Brady with a PAC. But like I said, if you're gonna be looking at it and making your own interpretation, you like I said, you're still gonna count this one as a beat. You say 1, 2, 3, 4, 5, 6, sinus rhythm with a PAC. Let's see what this one is. It says this is a non-conductive PAC. So it's marching out. There should have been somewhere right here, but it didn't. It doesn't have a QRS. Like this one has a QRS. It's a PAC. This one should have been one right here, but there's not. But if you look closely, you see it's just giving you with this little dot right here. It's telling you to look closely at this. There's most likely a PAC. I'm sorry, a P wave hiding in the T wave somewhere. So that's a non-conducted PAC. It's non-conducted. It didn't go all the way. It's supposed to look like that, but it didn't. It's a non-conducted PAC. Paroxysmal atrial tachycardia. You just say PAT or PSVT. At work, you'll hear PAT or PSVT, and I think I just want to say that I think it just goes depending on the heart rate. I think it's like if it's I think if the heart rate is less than 150, I think you'd go with PAT. If it's more than 150 the heart rate, you'd call it PSVT, and it's talking about the small little run that you'll have. That's what a PAT is. And I'm going to read it real quick. It says it's a sudden burst of 3 or more PACs. 3 or more. Because 2 is called couplet PAC. It has a different name. But if it's 3 or more PACs in a row that I can't say that word, usurps the underlying rhythm and then becomes its own rhythm for a period of time. The term paroxysmal refers to the rhythm that starts and stops suddenly. It's a rhythm that starts and stops suddenly, a paroxysmal atrial tachycardia. PAT resembles sinus tach but with a faster heart rate. In order to diagnose PAT, the PAC that initiates it must be seen. So the rate is saying for PAT, it's saying the rate is 160 to 250 on the atrial tachycardia itself. That means this one. Okay. The rhythm it interrupts will have a different rate. So in the computer is going to tell you, like I said, the computer usually does this for you. It's going to tell you the heart rate that the patient is running. So this one looks like they're running a sinus rhythm, and when you're going to make the interpretation, you're going to say sinus rhythm with a PAT run. Now they're going to want to know was the heart rate, and they might want to know, they might not, but you'll know what the rules are for that wherever you're going to be working at. If you need to tell them, most likely you do, what the heart rate, what's the highest that it went in the PAT run. So the P waves, the atrial tachycardia P's will be shaped the same as each other, but differently from the sinus P waves. Atrial tachycardia. That's another way of saying. Well, it's in the name. PAT. It's in the name. Atrial tachycardia. It's just tachycardia. It's just that run. It's saying that run. The P waves are going to be looking different than these ones over here, because they're all squished together. It's giving a run. If it has a lot of runs, you'll say frequent, or if it's not, you'll say occasional beats or occasional runs of PAT, or like I said, PSVT is another name that they use depending on the heart rate. It just depends on the place that you work at. I've noticed that sometimes they use different names. Atrial flutter is a rhythm that results when the irritable atrial focus fires out regular impulses at a rate so rapid that the fluttery pattern is produced instead of a P wave. So it's not a P wave. The atrium is firing out its impulses so fast that the AV node, bombarded with all these impulses, lets some through but blocks others. Imagine a tennis ball machine firing out tennis balls so fast that there's no way you can hit them all. You end up ducking to protect yourself. The AV node is the gatekeeper, the protector of the ventricles. Impulses must pass through it to reach the ventricles. Impulses that are too fast would provide a dangerously fast heart rate. So the AV node selectively blocks out some of the impulses, letting only some through. So atrial flutter is going to be very easy to like distinguish or whatever, because you're going to see flutter waves. You're going to see flutter waves. You're not even going to see, you can't really see P waves or anything like that. You're just going to see flutter waves. That's what they're called. So this one should be easy for the most part to to identify. The rate is 250 to 350. Ventricle rate depends on the conduction ratio. Sometimes they'll ask you how many flutters to each ratio. This one would be, I guess, 3 to 1 or something like that. 3 to 1, I think that's how they say it. Sometimes they say 2 to 1. It'd be 2 flutter waves to 1. That's what it means when they say ratio. And if it varies, just say ratio varies or something like that. I'm not 100% sure, but it's let me see if it says right here. Regular, if the conduction ratio of flutter waves to QRS complex is constant. Irregular if the conduction ratio varies. Can look regular but interrupted at times. So like I said, no P waves, flutter waves are present instead. These are sawtooth-shaped waves between the QRS complexes. Okay, so so there will be 2 or more flutter waves. 2 each QRS. All flutter waves march out. They're all the same shape. Yeah, you for the most part, this one should be really easy. Flutter, atrial flutter, atrial fibrillation. During atrial fibrillation, hundreds of atrial impulses from different locations all fire at the same time. As a result, the atria depolarize not as a unit as they usually do, but rather in small sections. This causes the atria to wiggle instead of contract. The AV node is bombarded with all these impulses and simply cannot depolarize fast enough to let them all through. Every now and then, one of these impulses does get through to the ventricles and provides the QRS. It says atrial rate is 350 to 700. Ventricle rates vary. Atrial fibrillation with a mean ventricle rate greater than 100 is said to have RVR, or rapid ventricle response. So, and I'm going to show you right now. By the way, the regularity for atrial flutter is, it could be regular or irregular, and that's the same thing with atrial fib or atrial fibrillation. Irregular, completely unpredictable. It's usually, though, irregular. It usually is. I'm probably mistaken. Atrial flutter might be regular or irregular, but AFib is mostly irregular. See the AFib on the top? It's not regular. You don't see a P wave. No P waves are present. Fibrillatory waves are present instead. So it's just like little wiggly line all across. So it's irregular. No P waves. No T. Well, T waves, I think they're still there. It's just because it's supposed to repolarize, so it still has to go. The cells have to go back to their normal state. So there are waves in the baseline between the QRSs. There's no P waves. So if you ever see a rhythm with no P waves, but you see the real thin QRSs, most likely and you see the wavy line, most likely it's a AFib, or atrial fibrillation. SVT, short for supraventricular tachycardia. So some of the, I guess what you call rules for that to be called the SVT, or supraventricular tachycardia. The rate has to be 130 or higher, usually greater than 150 beats per minute. The rhythm should be regular. I mean, it still marches out. The P waves are not, you can't see them. You can't see them. They're probably there, but you can't make out. So this is an SVT. SVT. So it's really, really, really fast, but you don't see no any P waves. So the PRN cannot be measured since P waves cannot be possibly identified. QRS is still less than 0.12 seconds. Let's look at some practice strips really quick. This one, the first one, most likely an SVT. Heart rate is at 150. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, I don't know. I put 150, but yeah, it's probably 140 beats per minute. This one, it looks like, and I did these back then, so I quizzed myself and everything, but most likely a sinus Brady with a PAC. You see that? Marching, 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 that one, and because of the heart rate, so it's sinus Brady with a PAC. This one, what do y'all think this is? It looks fluttery. So most likely is atrial flutter. I had put in the beginning AFib, but it's not AFib. You could clearly see flutter. See, I got a lot of stuff wrong back in the day because I was barely learning all this, but atrial flutter, it says with a 5-to-1 ratio, 1, 2, 3, 4, unless you're counting, I don't know what I was, the back of the book says 5-to-1 and 6-to-1. 1, 2, 3, 4, 3, 4. I don't know what it's counting, but anyways, the ratio is 5-to-1 or 3-to-1, 4-to-1, whatever. Just count these little flutter waves, and that's what you get, the ratio. Let's see what this one is. Well, you can see any type of, you might be confused if you see every now and then, but like I said, if you want to call it a WAP or a MAT, you must be able to see some other looking P waves, but I don't really see too much. So I'd rather go with AFib. It's irregular. It's mostly doing a wavy line all across. And a lot of times, if you need to look back at the history of the patient so you can make sure before interpreting what you feel, it's okay to ask somebody, or it's okay to look at their history of the patient. This one looks different, right? Doesn't look so beautiful like this book, how they say. But this one most likely is flutter. This one might be 1-to-1 ratio or 2-to-1 ratio, something like that. See? You can still see in another one that it's like a flutter. So like I said, to calculate the heart rate, count these, and that's what that is, but that's most likely a atrial flutter. Let's do one more. This is irregular, and I do see P waves. Let's see what the 1, 2, 3, 4, 5, 6. These are the little things that I was counting before. I was back in the day, I used to count the little squares, the little itty bitty squares, because I didn't have a caliper at the time. A caliper, like I said, it's like it has like two little dots, and you get to see, you set it at a certain measure, and then you're counting to see if it's marching out, or if it's, I didn't have one, so I was just counting the little squares, and I would see that they're off by so many, so I knew that it was irregular rhythm, different P waves. Let's count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what do y'all think this is? I see different P waves here. I do see P waves. So, yep, MAT, that's what I would call it.